Hello. Our goal in this video is first to determine if the improper integral from 0 to infinity of 1 over exponential of x plus 1 is convergent or divergent. If it is convergent, we will try to compute its value. The integral from 1 to infinity of 1 over exponential of x plus 1 dx is an improper integral because the upper limit of integration is infinity. The first thing we have to address here is the convergence or divergence of this integral. We will use the comparison test to determine the convergence of this integral. We will compare 1 over exponential of x plus 1 with the standard function, exponential of negative x. First of all, it is worth noticing that exponential of x is less than exponential of x plus 1 for all real number x. Consequently, this implies that 1 over exponential of x plus 1 is less than the fraction 1 over exponential of x. Therefore, the integral from 0 to infinity of 1 over exponential of x plus 1 dx is less than or equal to the integral from 0 to infinity of exponential of negative x dx. The integral of exponential of negative x dx is equal to 1. Because the antiderivative of exponential of negative x is minus exponential of negative x. Moreover, the limit as x goes to infinity of exponential of negative x is 0, and exponential of 0 is 1. Thus, the integral from 0 to infinity of 1 over exponential of x plus 1 dx is less than or equal to 1. Therefore, the integral is convergent. In order to compute the value of this improper integral, we need to first find the antiderivative of 1 over exponential of x plus 1. As we look at this function, the only method that can be used at this stage is the substitution method. We set u equals to exponential of x, then do is exponential of x dx. Thus dx is equal to 1 over exponential of x du. Now, let us set the new endpoints of our integral. When x is equal to 0, u is equal to 1, and when x is equal to infinity, u is equal to infinity. Therefore, the integral from 0 to infinity of 0 dx is equal to the integral from 1 to infinity of 1 over u times u plus 1 du. In order to find the antiderivative of the function 1 over u times u plus 1, we need to use partial fractions. As you can see, this function is a rational function. Its numerator is the constant 1, and its denominator is the product of two irreducible polynomials, u and u plus 1. Therefore, we need to decompose this function into a sum of partial fractions. From the partial fraction theory, we know that the rational function 1 over u times u plus 1 can be expressed as a over u plus b over u plus 1. Our goal is to find the values of a and b. We need to find the constants a and b such that the fraction 1 over u times u plus 1 is equal to the sum of two fractions, a over u and b over u plus 1. The first thing we should do is to reduce the sum of partial fractions to the same denominator. So, a over u plus b over u plus 1 is equal to the new fraction with numerator a times u plus 1 plus b times u, and denominator u times u plus 1. Please like this video and subscribe to our channel. Thanks to those who have already done so. The next step is to expand the numerator of this new fraction. The numerator of the new fraction is u times a plus b plus a, and its denominator is still u times u plus 1. This gives us the following system of equations: a plus b equals 0, and a equals 1. When we solve the system of equations, a plus b is equal to 0, and a is equal to 1. We easily find that a equals 1, and b equals negative 1. Now that we have the values of a and b, we can simplify the expression of the integral. So, the integral from 1 to infinity of 1 over u times u plus 1 du is equal to, the integral from 1 to infinity of 1 over u du, minus the integral from 1 to infinity of 1 over u plus 1 du. We know that, the antiderivative of 1 over u, is natural log of u, and the antiderivative of 1 over u plus 1, is natural log of u plus 1. The integral from 1 to infinity of 1 over u times u plus 1 du is equal to, the antiderivatives log of u minus log of u plus 1, evaluated at the end points, 1 and infinity. Therefore, the integral from 1 to infinity of 1 over u times u plus 1 du is equal to the limit as u goes to infinity of the natural log of u, minus the natural log of 1, minus the limit as u goes to infinity of the natural log of 1 plus u, minus the natural log of 2. This can be simplified as the limit as u goes to infinity of the natural log of u minus the natural log of 1 plus u, plus the natural log of 2. This can be further simplified as the limit as u goes to infinity of the natural log of the fraction u over 1 plus u, plus the natural log of 2. Using the continuity of the log function, this expression is equal to the natural log of 1 plus the natural log of 2. This is because the limit as u goes to infinity of u over 1 plus u is 1. In sum, the integral from 0 to infinity of 1 over exponential of x, plus 1 dx, which is equal to the integral from 1 to infinity of 1 over u times u plus 1, is equal to the natural log of 2. Finally, the integral from 0 to infinity of 1 over exponential of x, plus 1 dx is convergent, and its value is natural log of 2. Please like this video and subscribe to our channel. Thanks to those who have already done so.